How does convection work as a heat transfer mechanism? Imagine a pot of water on a stove. As the water heats up, you notice the bubbles rising to the surface. That movement is a perfect example of convection in action. Convection is a way heat moves through fluids, which include liquids and gases, by the actual movement of the fluid itself. Unlike conduction, where heat travels through direct contact between molecules, convection involves the bulk flow of the fluid carrying heat along with it. When a fluid gets heated near a heat source, it expands and becomes less dense. Because it is lighter, it rises upward. Meanwhile, cooler, denser fluid sinks down to take its place. This creates a continuous cycle or circulation pattern within the fluid, which helps distribute heat evenly. There are two main types of convection. Natural convection happens when fluid motion is driven solely by temperature differences. For example, when you heat water on a stove, the warm water rises naturally, and the cooler water sinks, creating a convection current. Forced convection, on the other hand, involves an external force like a fan, pump, or blower moving the fluid. This method is often used in heating or cooling systems to speed up heat transfer. The effectiveness of convection depends on several factors. These include the temperature difference between the fluid and the surface, the properties of the fluid such as how thick or sticky it is, and how fast the fluid moves. The shape and size of the surface involved also matter. A key idea in convection is the heat transfer coefficient. This number tells us how well heat moves from a solid surface to the fluid flowing over it. It depends on the fluid's properties and how fast the fluid is moving. For example, when you boil water, the hot water rises and cooler water sinks, creating a convection current that heats the entire pot. In a room with a radiator, warm air rises from the heater and circulates around the space, distributing heat evenly. Fans cooling electronic devices blow air over hot components, helping to carry away heat efficiently. In everyday life and engineering, convection is everywhere. It helps us cook food, warm buildings, and cool computers. Understanding how convection works allows us to design better heating and cooling systems, making our environments more comfortable and energy efficient.